Hello and welcome to part 4 of my stream. Glad to see you here. Could you guys please confirm in the chat that you can hear me alright and the music is not too loud? Okay. So yesterday we did a couple of things. Basically we parsed the XML file and we were dealing mainly with this interfaces stuff, where when you are going through the nodes in this XML file, for some of them, like here for the node number 16, it has an interface which is point-to-point interface, and it connects to another node which is not yet created. So like here, this node with ID 16 is connected to the node with ID number 17, but node 17 does not yet exist, so we couldn't create the links between objects in Python. So we either had to defer this object creation, or we had to create this object on the fly, and then later when we hit this object, we would have to get the object that we already created and update parameters. So we spent yesterday on this, I think almost like 3 hours or so. It was probably one of the hardest things here. Yeah, so what are we going to do today? I also put a sticky note here on the right, which will be during the whole stream, so people who are joining in could read and get some idea about what I'm doing currently. So let me go also to the code. So I stopped on, so yeah, yesterday we did some additional methods here for the node, and we did what? We also had some logic here for the interface, not too much, but for today we have to write this class, and this particular class will represent all connections basically. So as I explained already a couple of times, in UNL they allow a situation where there are interfaces are connected to the same segment. Никто не любит face. Thanks for following. So sorry. Yeah, I was, and I just lost my thought, but that's fine. So yeah, in EVE, they have a notion of network, and you can connect multiple interfaces to the same network, and it will act as a hub, which you don't see on the topology, and this is why they had this notion of network in the first place. In GNS3 though, there isn't such a thing, so all links are point-to-point, and if you want to have one broadcast segment, you have to add either a hub or the switch on your own. Okay, so what I'm going to do right now, we have to parse through the things that we have and basically create links for all of them. And probably, while I was saying this, I realized that probably it would make sense to start with class topology, which I listed here on the stack as a second item. But now that I'm looking at it, I think it would make sense to move it higher. So our topology will have these nodes, it will have these links, and instead of having all of the logic here in the EVE to GNS3 converter file, where I have like parse nodes, parse configs, and so on, I think I can move it like as a methods of the class topology, which could potentially make sense. Okay, so let me also bring up my terminal. Not that we will really need it for now, but just in case. Yep, so let me run this code to make sure that I didn't break anything from yesterday. So in this particular case, there was some print statement. Let me also make this bigger. So at the very end, I was just printing all of the nodes, and I also had the breakpoint somewhere here where we made sure that all of the links, all of interfaces and links are fine between the objects. Okay, so I think I will move this to the top of my stack, create a topology object. It feels more natural for me to start with that. So, okay, I think for topology I'm going to create another file, and probably I will also rename this. So let's say network model. This will be nodes. Okay. Or node. Let's have node. So it should change everything in the associated files, and then I also need to create a new file which will be topology. Okay, and this will be class topology. While I'm doing that, I have an ask for you guys. So if you open this stream full screen, could you please confirm that you can read the information on the right, so that the text is not too small? Oh, hi Jumpy. Nice to see you again. Okay, so it seems on the stream there is no chat. Okay, just give me a second then. So for some reason my chat on the left is not displayed. Okay. Okay, so I'm creating this class topology. We will have the constructor in it here. So yeah, I will have to move some of the logic here. So probably this I think, yeah, I'm thinking if I should include, I think I will include just source XML file. So the topology itself is created only by source, no, if XML file. or if XML, let's just put it there, and it can also be none. And now let me use these amazing features invented by developers. Okay. Now I probably also want to parse it as well. So let's say if or let's say parsed if XML. So I'm moving this logic there. And obviously I will have to import the XML to dict. Okay. Okay, so this will be very similar. So I will have a method which says def parse networks. Let me just put it like this. So, and I will copy the whole thing here. Oops. Okay. Yeah, so I'm going to change something here. So the empty topology can have this list of those EVE networks. It will have a list of nodes, and it will have a list of links. Okay. Now we also may include self ID to network, self ID ID to node, stuff like that, and self ID to link, but I'm not yet sure we will need this. Let's just have it. Not sure if we need this. Okay. So here I need networks dict. And actually I don't need it. No, I don't need it. So I can parse just self. To be self. I don't need arguments. I don't need this, but I should be careful here. Okay, so I also need to change some imports. For now I will just do the whole thing. Well, actually, I wasn't C developer before. I'm trying to be one because this is what my my master program requires. That I'm doing in parallel to my work, but this is actually a convention in Python. So, like Python style guide, PEP says that you need to use underscores. Okay, I also still don't see the chat here on the screen. Just give me 1 second, guys. I will try to re-add the chat. hopefully it will work. Okay. Okay, the chat is there. Perfect. Woohoo! Got it working. Nice. Okay. Okay, so Parse Networks. Okay, so I'm going to call self Parse Networks. Here I will have to change this networks dict. I will get it as the first argument, sorry, as the first variable here. So this will be source topology dict, blah blah blah. And I have instead parsed EVE-XML. Okay, so I don't need this. So I need now to add to self.networks, self.id to network. Okay. Yeah, this looks good to me. I don't need this return anymore. Right, yeah, I don't need it. I don't need this. Okay. So I will fix this documentation later. So parse nodes. No, parse nodes. Okay. So instead, this takes. Let me also see how it's called. Like this. So it will be self, and that's all. The first argument will be nodes dict, and it will be. Oh, and of course here it's self parsed. Okay. I don't need this ID to network. I don't need this to thingy. Okay. Yeah, this we need to rework this. We need to do this as well. Let's also edit. So here, add documentation for topology methods. Okay, so nodes dict is fine here. I don't need to print this anymore. I need to change the way I call this though. So to be self ID to network, self ID to node, and self.nodes I append. So great. So now it's self.parse nodes. We can also, let's actually do the following. Let's add here def parse XML self, and we will call here self parse networks, self parse nodes. and this will be self parse XML. Okay, this looks good. Okay, so I parse the nodes, I parsed the networks. What else? Okay, this part will need to be changed. So oh, there is also parse configs. So let's copy this. Well, I say copy and then I cut it. Okay, this will be self parse configs. And here is the same thing. We will need to get config sticks as a first stage, and it will be something like this. Okay, this will be self id to node, no, so to do, to my new blank lines, self, let's import missing library. Okay, this is good, this is good, this is fine as well. Okay. And then there was also, you'll have another function which writes a config, so which basically does this part. Yes, so here is for like the sake of saving some CPU cycles. I did it in one loop, but these are two completely different actions, so I'm thinking like probably having an efficiency here that I will have like a couple of loops is better than having the like efficient code but which is not really like readable. So like mixing, like here I write configs and so on, because I'm moving this to the topology, so I will have like a method that does that. Oh, hey Alex. Everything is great, thanks for asking. Tell me about yourself. Yeah, so I think I will move at least this part. Oh, and there is one parameter that I didn't pass. I think I will pass these arcs as well, so that I can access destination directory and stuff like that. Okay, so it will be like args none, and here will be self args.args. So I can copy pretty much everything here. No, not this one. So this is again different action. These two are different actions. But this part in between though is fine. So you will have a function, let's call it write configs self, and it will do this magic here. Okay. Okay, so we are deleting directory, deleting configs directory if exists, and creating an empty one. Okay, this part does not belong here. This part also does not make sense here. And here we have to just change that for not in self nodes. We are going to do the same thing. JavaScript, that's a good question, and I don't think so. So not in the nearest future. I'm very bad at JavaScript. Like I can write probably just basic calculators, that's all. And every time I have to do front end for the web, I cry in front of a mirror for at least 30 minutes. Okay. So this works partially. I think I will also want to move this get canvas to the topology. Yeah, I think it would make sense. And move these parameters, GNS canvas scale and so on. Yes, exactly. This is what I did for one of my latest projects. At some point okay, let me actually find somebody who will enjoy it much more than I will. But it also may be, you know what, it may be that I don't like it because I don't know it well, right? So it may be also the case, so that I don't like it. I don't want to do it just because I don't know it as good as I know Python, for example. So it's easier to stay in like comfort zone, right, rather than you know, go into completely unknown territory for you and do the same things that you could do in Python. All depends on the application, right? But yeah, so for now I don't do it. Okay, so I will leave get arguments. It feels natural to leave it in like main file. And let me also edit as create a package here. And it is funny, but the only thing you need to do to create a Python package is to just add underscore init file. It can be even empty. I think this can be changed to main. and oh, it's already done. Okay, so again, let me go back to that main file now, so I can grab that. Okay. So here is self. These two parameters, I will have to get them from the node.py. And probably put them in topology. It's again feels like a proper place for them. And I can put them even like here, so as they are constant, so they will be like part of the class. So I can refer to them also with self. Okay, I also don't really need to return it. Oh, and also need to import mass module. I don't really need to import it, I can just save them to like self. Let's do it. Self GNS canvas size. Okay. Let's add them as an instance, sorry, as an attribute during when we call constructors, so it's explicitly defined. Okay. So probably this is a good time for me to get rid of all of that stuff. Oh, there is one point where it will break as well. So in the node.py, and hold on, here from the topology, let's import it like this from .node. So now that we have a package, so I want to use like this relative dot way of referring to the package, relative import basically. Topology, no, node, because node also was referring somewhere to GNS3 scale, I think, and I don't have it anymore. And I don't see it as well. Canvas. Oh yeah, here. So these parameters are not there anymore. So I will need... okay, I will need to... No. Well, I can import topology. Here, from topology... No, sorry, from import errors, from the topology import topology. Oh, I think, okay, like this, and now I need to say topology dot scale, topology dot So canvas size, I can run it as part of the init statement in the topology now. I can call it here. I can say cell.get canvas size, and I save it here. So, and then I will have to go through each node and convert coordinates. Okay. The reason why I'm stuck is I am thinking my concern here is that I'm going to iterate over nodes over and over again. So if I like make it beautiful, I will have to iterate over those again and again. So like I have one loop to let's say parse them, one loop to like convert coordinates, another loop for writing configs, and so on. And it feels bad, but then if I redo it somehow, then I also will not really like it. So then like I will start mixing these different actions in like one loop. So this is what I don't want to do. I think I will just, okay, for now I will just have a loop and I will iterate over like loop couple of times. I think I will be able to live with myself after I do this. Okay, so I still haven't refactored this yet, but I'm getting there. No, I'm Ukrainian. Okay. So you also add another method here, which will say def change no, how am I going to call it? Add GNS3 coordinates. Let's leave it like this. But if you have better suggestions, please do. So what is this going to do? It will say for node in self nodes, I'm going to going to call this to thingy. Wait, no, this is I can't recall me writing this. I mean, because it's such this code does not really make sense to me right now. So I mean, here, why do I do get if I can just set them? Set GNS coordinates, GNS canvas size, and I return them. Like, no, just self dot what, GNSX, or how did I call it? GNSX, GNSY. Okay, so GNSX self GNSY. Fix documentation in not set GNS coordinates. And here I also need to refactor main code. Okay, so let's move this here. Okay. Okay. Yes, so we are going to do what? We are going to say not set GNS coordinates, and I have to just pass self dot GNS canvas size. And that's pretty much it. Okay, cool. I can actually say set here as well. Okay, cool. So now let's refactor this. So I'm going to keep convert topology for now. So this is going to get arguments. We are going to read the source file, and then we are going to parse file. So this is a point where I will change everything. So we'll say topology is equal to topology, and I of course didn't import it, so I have to say from topology import topology. Okay, and I'm going to say if XML is equal to source topology file. Okay, now this thing will be done automatically there. This will be done there as well. This will be done there as well. This will be done there as well. And set GNS3 coordinates. And this will be done as well. I think everything will be done there. Let's try. So, like 5% chance it will work without crashing. No, of course it will not. No module name main. Hey, set who12. no module named main _ main topology. Oh, hold on. So I'm not sure though. And it breaks on line 12. It breaks here on importing from topology, import topology. Let me just Google this for a second. I am not Russian, I'm Ukrainian. Okay. Seems like this. Main is not the package. Simply remove the dot from. Yeah, it seems like I don't understand 100% how relative import works. But let me just for a second change this back. So it was give to GNS3 converter. Nope, I still have the same. So I'm running the module as main by passing the mod 1 as an argument to the interpreter. You know what? Yeah, I think I get it now. Yeah, so I'm calling this script here, if to GNS3 converter. I will just do one thing. So I will rename this back to main. And if I'm going to say PyCharm does not allow it to do it, I think. Let me do it from command line. So if I say repositories if to GNS3 converter, I think if I say python 3 - m main, Okay, for now I will just remove all of the package references. Okay, and this I will rename this back. Then I will have to change it back to non-relative import. Here. And here. Okay. What? From topology import topology. Cannot import name topology. So there is another mistake here. Okay, so it will still say cannot import name. Okay, so I'm importing topology, which refers to the node. Okay, I think this is just circular import problem here. So it says cannot import name topology. Fine. From topology, import topology. Yeah, so I'm going to delete this. And I'm going to need to pass this. Need to change this here. And I need to pass it here. I need to say GNS canvas scale. Okay. Instance defined outside. Okay, I also have to add them here. Self GNS X equal to 0. Self GNS Y is equal to 0. Okay, and now I have to pass the variable in the topology file. I have to pass that variable inside GNS3 coordinates. Self GNS canvas scale. Right. Okay, this worked. So now, did I delete everything? Yeah, so let's do this. I will have some print and I will put here the breakpoint. And let's analyze. And I'm curious about networks, sorry, nodes. So I have all of the nodes, and the problematic one was 617. And I set a new coordinates here, cool. I have list of interfaces, and we actually refer to another device. Oh, I think I see some issue actually. Oh no, it's fine. So, okay, this refers to This is fine. The problematic one was this one, 17 interfaces. And I'm connected to another router here. Perfect. Yeah, so it seems everything is fine. Do we still create configs? Which we do. Great. So I can delete all this code now. I think I need to move something to a different place. So what I don't like is that this is just a constructor. It parses, that's alright, but then it like changes structure on the disk, and I like didn't call it anything explicitly, so I called this like oh no, I don't call anything. That's right. Okay, let me do this. Let me delete this configs directory. Let's run it again. Okay. Oh, okay, it's not created. So yeah, that's fine now. So then it would be like topology write configs. Now I run it again, and it crashes. Oh, okay. And this directory is back. Perfect. Okay, so refactor main code done. If to GNS3 converter codes done. This function will be also part of topology. Okay. Okay, great. It says method build genetic topology might be static. Yeah, okay. For now it doesn't matter. Okay, so now I think I will just move this code to main, and I will delete this. It's so small, so I think it's so fine. Let me do this. Let me can remove all of these imports. Let's see if there are some leftovers. No, seems to be fine. Great. Okay, done. So create topology object which will contain all nodes and links. So now I think I have to move to create links first. So, and links are in node here. think I can also move this network and link somewhere to another file, but let's see, let's for now keep it here, but if something we will change it. Okay, so I need some help with naming variables. So link class will contain like one interface object and another interface object. That's all. And we will have some convenience methods as well. So link object, what it's going to have. So it will have so it will have UUID, which will be automatic. And the reason why I say this is because this is how GNS3 does it. So for example here we see that the link has ID and this is like UUID format. So let me explore this as well. So IPython import UUID. I forgot how the function is called. Is it UUID4? UUID. UUID4. Yeah, this is UUID4. And you know what? Let me actually go to GNS3 GitHub. Let's see. And it will be GUI. And in the code, oh, they released yesterday 2.1.1. I didn't even notice. Seems like a lot of bug fixes. Okay, I will check this out later. So UUID, let's see. From UUID import UUID4. Okay, cool. So we will have to do it actually, and we will need to start adding those UUID to to all other objects as well. Okay, so I will have to import this UUID, import UUID. So this will be UUID4. Oh, what happened? UUID4. Oh, I cannot do this. Oops. Oh wait, no, I actually can. I can do it myself. Okay, cool. So I have UUID. And again, this object contains, basically one node. Sorry, not even one node. It contains one interface object and another interface object. So how would I name it? And I'm thinking, do I want to keep them in separate variables or like in one? Let's see this GNS3 file again. Links, filters. So this links contains nodes and that we connect to nodes. and this is a list. I'm not sure. Not really sure. I think if I just add like self interfaces, let's do this self interfaces. This will be 2. And I can add, I will have a function add interface to link, and this function will take interface, and we will have the following. If length of self interfaces is less than 2, then I will do self interfaces dot append. Otherwise, I'm going to raise an error. Wrong invalid link. And it will be errors.invalid link. The link can't connect more than two interfaces. And then I need to add this error to my errors here. So it will be class invalid link exception. Okay. That's pretty much everything. So I create a link, or I can pass like tuple. So, or let's say just list as well. So I can pass interfaces. By default it is none. So, and let's do this. If interfaces is none, self interfaces is equal to empty list, else self interfaces is equal to interfaces. Okay. And maybe we even do this list from interfaces, because I could pass a tuple. So just to confirm that this works. So if I have stuff like this, I have a list. Okay, cool. So this is a link object, pretty much straightforward. Now the node itself, we also need to have UUID. So UUID self UUID is equal to UUID4. Okay, and topology will also need to have UUID. So self UUID is equal to UUID4. Okay, nothing has changed. It's still working for now. So I have links now. I have to thinking how should I do it. So I need to take every so here topology. Oh, and this is actually done. So let's put it to my finished list. Okay. So this is still not done. So I have to change something in parsing here. So I do this, I parse XML, this is fine. In parse XML, I parse networks, parse nodes, parse configs. Here in parse nodes, and then self create links. Okay. And here there will be a function called def create links from self, and this is going to do two things. No, this will be create links from networks. Create links from networks. And then for the node object, I need to change import here. I need to say I want to import. Oh no, link is here in the same file. So the node class, whenever we parse that serial link, I want to add it to links here. Pretty complex logic, but that's fine. So I'm going to create a link which says I cannot refer back to the topology because I want to save all those links separately, and I cannot do it now because I don't have any kind of link back to the topology. Okay, so I will have to add it. So topology is equal to none, and you have self topology is equal to topology. And whenever I create a node object, I have to pass it. So here, parse nodes, and I should pass topology. And probably it does not make any sense to pass this to anymore. But if I remove, I should do it carefully. So node from dict should also accept topology. Okay. So it will be here, topology is equal to none. This will be topology ID to network. Actually, I don't need this. I need to say params self topology is equal to topology. Here I need to just return params. This also needs to change. These two are not needed anymore. So this will be self topology dot id to not id. Okay. Topology dot id to node. Okay, fine. Parse node from dict is fine. And now there are a couple more places, like here. This has to change as well. Self topology.id to network. Self topology.id to network. Here I have to specify that topology is equal to self topology. Oh, sorry, my music again stopped. I'm pretty sure I broke everything right now, but yeah, let's see. Okay, I will just run this to make sure I broke it, which I did. Oh, but not for that reason. Topology object has no attribute topology. Oh, okay. Here is self. Okay, this worked. It seems like it was not so much pain as I thought it would be. Let me see. So let's say nodes, and again node number 17. It should have link back to the topology, which it does. It still, yeah, so it worked fine. And let's check also like this one, 17. Topology, okay. Yeah, I didn't break it. Nice. So now we go back to that create topology object which will contain all nodes and links. Right, so we still have to figure out when we add that serial links during parsing somewhere here. Parse interface dict. Great. So when I create this link between those two, I want to actually name it as a link. I want to say link is link interfaces. In tuple I say local interface, remote interface. And also let's add that interface. Let's say local interface dot link is this link. So I make this two-way check. So then I can always check that there are, like, you know, an interface can be connected on, like, can be a part of only one link, for example, if that's what I want to do. So like this. Now I also need, for the interface class, I need to add none. Like here. Self dot link is none. Oh. Okay. So now I should be able to have links, and let me also run debugger. So topology, oh no, I created links but I didn't add them. So right. Here. Create link object if the link is point to point. Okay. So now I also have to add this link to collection of links. So I'm going to say self dot topology dot links append link. And let's run debugger again. So now in this topology object I should be able to have at least a couple of links. And then here I have id to link, but I don't think I will actually need. Okay, so I create a links, and each link connects two interfaces. This is interesting. Here that the EVE name is none. Okay, so this is some bug that I have to fix. And I think I have to fix it right now. So point to point interface has name none. And this is what? This is not 17 LA R1. Here. And I can see here the name. Okay, so this seems to be like a bug from yesterday, which I just missed. It's good that we noticed it right now. Now I have to understand where it's coming from. So it's all somewhere here. So when I create remote an interface, I say get an interface, I say error missing interface. Okay, I never update that interface. So if I created it here, I just don't update it anymore when I do parse interfaces. Let me see the code for parse nodes, parse interfaces. So what does this logic say here? Oh, right. So I parse interface the dict, but I don't even pay attention that I may have already created this. Yeah, so this will require some additional code. So when I do here create interface, I do not update interface details later. So here on the very top I have to say, well, let me check if I already have it. So let's say self.get interface, and I think I raise an exception here. Get interface, create get interface, we're missing interface. So I then call this, I say try interface is equal to self get interface for this parameter, I think ID, yeah, interface ID. So if interface ID except errors missing interface. So I go to all of this stuff only if it does not exist yet. And if it does exist, so I need to do this. I need to call really only self.name. Sorry, I need to just update this. I need to say if this interface is already there, please update its name. So interface.name will be EVE interface.name. That's the only thing I really need to do. Okay, let's debug it again. Okay, topology links. So it contains a couple of them with two interfaces. There is interface 1, there is interface 2, and name is not updated. Interesting. ID is there, but name is not there. Yeah, and this is the only thing really missing. So why this didn't work? Let's see self.create interface. Do we add? We should be able to add to self.interface. Okay, cool. So let's see. Oh, hey man. Nice to see you as well. How is it going? Thanks for following, man. Yeah. Just do something fun. Like I'm doing here. Some Python or, you know, whatever you like. Definitely it's not a good time to touch anything on production network. Oh, I see the problem now. I think. How did I miss it before? I have absolutely no clue. So like I don't return the interface, right? Well, it's still not the problem though. So let's see. For every interface, I'm going through parse interface dict, which is right here. So first thing, I get the type, I get the interface ID, I get the interface name. Now I check, do I have this interface already? For some reason this object does not have it. Even though I created the interface right here. So I'm going here, I'm going through this code and I'm saying if remote node is known, I'm creating a node. Then I'm trying to get an interface, remote interface. If there is none, I am creating one. It seems like I'm creating it fine. Hey, woo, yeah. On the right there is a sticky note. This will be probably a good good thing to read so that you would be up to speed. Let's see, bug. So for now I don't see why it's happening though. So first, whenever I'm parsing it, I'm checking, is this interface already there? And the way I do it by invoking getInterface function, which takes interface ID. Oh, sorry. Okay, let me give you a quick overview. So, yeah, I'm writing a converter of topology of one networking simulator, which is called EVE, to GNS3, and in Python. So this is what I'm trying to do. Probably though, if you are on mobiles, then you will not be able to like read the code itself as well, right? Yeah, I'm just doing live coding, basically. Yeah, so right now I'm trying to catch a bug, and I cannot find it. So I'm at some point I missed like one reference in one object. I don't have a reference. I don't have a proper attribute set, and it should be there, but it's not there. So I'm trying to understand what the heck did I do. Let me run debugger again. So okay, topology has links here. Yeah, so I also, like, if you are interested, the whole thing is recorded and everything is on my YouTube. Actually, like, previous parts I'm going to upload like today. They're almost ready to be uploaded. Yes, still this does not work properly. For this link, for every link actually, the second interface is wrong. So let me see how this interface is created. I will do some check here. So I need to get node with ID 17, which will be topology.id to node 17, and then on node 17 I want to print all interfaces. Nice. What languages do you know, and what applications are you working on? Sorry, tell me what is WCF, because I don't know. Oh, cool, I discovered one more bug. Nice. I have 2 interfaces instead of 4. Great. Object 17 has 2 interfaces instead of 4. Nice. Cool. So what languages do you use right now? Got it. Do you like C#? Okay, I also need to change interface representation here. I really need to see the ID as well. Native programming language, nice. It's like in let's say 2030, right? The person is born and defined by nationality, native language, native programming language, right? Yeah, so for this particular project, I'm actually not doing network programmability, but this is my plan. So this, for me, this particular project like a warm-up, because I just started streaming, and generally my plan was like to have one big multi-vendor networking lab, and then start applying different kind of network automation that is currently there. Yeah, so here is like basically there are 2 network simulators, and to build topology in one of them it uses one format, in this case XML, and I want to use another one, so I am converting one to another. And it seems so easy until I started doing it. So like I thought, it will be like 2 hours, and now it's already like 9 hours. So it's 4th stream and 9 hours behind me, or maybe even 10. But it's interesting. It's cool. Okay, so what is going on here? So apparently I discovered 2 bugs. Yeah, I mean, it's not hard, I think, in most of the languages, unless you are like in C++ or something, but probably there are libraries to do it. It's like what is complicated in case of at least this one, or networks in general, is that networks themselves represent a complex model. So like you have nodes here which have interfaces, and those interfaces of different nodes are connected, and there may be like multiple connections and so on. So when you're trying to convert it to like object model, right? So there are some problems there. Okay, so the bugs that I discovered just now, I see that there is interface with ID 1 and interface with ID 17, but there are no others. Not good. And my original XML, okay, so these two are there. Only point to point. Cool. See you, and thanks for joining today. Okay, so yeah, I think I start getting it. I start understanding what is going on here. So let me get my parse nodes code back. And thanks for following. Let me get my parse nodes code in self topology. Okay, so here I say, okay, self node from dict, self nodes dot append. This one doesn't feel right to me. Self nodes dot append node. And because I think it will be part of the node code itself, or I don't do it. Yeah, so here self topology. I have this ID to node, so it already contains the mappings, so I think I can change this here. So I don't need self nodes actually. I can create a property which will say property def node self, and it will say I want to return ID self ID to node values. And I don't need to append it here anymore. And I can still call like for node and self nodes. It will break something, but that's fine. Yeah, I don't need this. Okay. Yeah. Great. So the bug is still there because this is not related stuff. So what I'm doing here in parsing, I'm checking the dict and then I'm calling node from dict. So let's go to node from dict. Here from dict, and it says I'm going to parse it. I'm going to get the node. If the node is none, I'm creating it. Fine. But this part is not correct. So I'm setting these attributes, but I don't reparse the interfaces for it, which I have to do. So I need to call self parse interfaces, and then I have to pass this params interface dict. Let's see, let's call it here as interfaces dictionary. Here I add this one. Unresolved reference self. Damn. Oh, no, it will be node self parse interfaces. Params interfaces dict. Oh, I just deleted it. Here. Interfaces dict. This will be interfaces dict, and this will be interfaces dict as well, and this will be node. Okay, so now I call node parse interfaces, and this is also where I should be extra careful. So I call here now node self parse interfaces, and I'm checking if interface already exists. I am adding something. If it doesn't, then I don't. Okay, nice. So now I have my 4 interfaces. The names are broken, so okay. Oh, okay, because it's EVE name. Nice. Yay, that's much better. So let me. And obviously I would have to write the tests for it, but I am not actually like really familiar with testing in Python. This is something that is on my to-do list. I definitely need to read some good book and start applying testing technique, because like, you know, this kind of bugs, if I didn't go through debugger, I wouldn't even notice that. Like, instead of 4 interfaces, I have 4. I have 2, sorry. And you know, this kind of stuff should be definitely checked. So like, you would want to check how many interfaces you have, how many you want to check that like their names are correct, that you can resolve the links properly. so let me go to the topology, to nodes. Okay, the networks, there are links. Links is referring to so here's one interface on one node, this interface on another node. Yeah, all seems great. Okay, cool. So for now I don't need this. Oh, yeah. Okay. So this bug seems to be fixed. Okay, so create a topology object which will contain all nodes and links. Okay, so I created some links. I created links for serial links. Interesting question. I don't know, like I have never, you know, like for some reason I don't associate YouTube with streaming. And Twitch has much bigger audience, and now they also have the separate section for like programming. So they have like community programming and like creative subsection. So, you know, it seemed for me a better place. Honestly, I was looking at some point. I was looking at live coding, and now it's called live edu, live education, because you know they were focused on programming only. I streamed there, but then at some point they had a thingy where in order to watch the stream you must register, and they also had some not very interesting offers for like paid membership. So like I stopped using that, but that platform was probably the most interesting for me, like, you know, the most relevant. It seemed though. Yeah, because like it was only for coding. Jamhurst, thanks for following, man. YouTube, like I didn't even consider YouTube, and I still like don't. Like no real evidence or facts or nothing, just like probably personal bias. No, Twitch doesn't automatically upload videos to YouTube. I have to record them locally with OBS, and then I merge them, and I merge them if I have to merge, and then I upload. Probably this is a good benefit of YouTube, yeah. Okay. So let's see. So I created links for point-to-point links. Now I have to create link objects for networks. Yeah, that's what I do. I do both. So for networks it can be tricky. So first we will consider networks where there are only 2 devices on the network, and those I can convert to links pretty easily. But if there are more than 2, then I will need to add a new node, which we'll call like generic switch or something like that. And yeah, but that's fine. That's not a big deal. So I think this should be in parse nodes function. Sorry, parse networks. And I don't see it here. Parse networks right here. No, it can't be here because I still haven't created because this is done first and then I parse nodes, so I cannot do it there. So oh yeah, so here is create links from networks. So, and I also don't need this actually. Self.networks append network, not needed, because I can just write a property which will get it for me dynamically. Property, so def network self will be return self ID to network values. Okay, so for network in self.networks, I have to check if this network has more than 2, and I will create a function here. So here in the network object I can create a function is point to point, and basically it will say if a length of self interfaces is exactly 2, then return true, and otherwise return false. Okay, so now if there are 2, then it's very easy to convert those to links. Or I can even say for every network I will create a function def convert to link self, convert to links. And the network object itself, it's probably better if it has topology. So it will be also self topology is equal to topology. So then when I add the network objects, I have to take that into account. Yes, I have to pass here self. Okay, so now I will have a function for a network in self.network, so I'm just call network convert to links. And then we go back to our node. Let's put it on the stack again. So create convert to links method in network class. So first of all, this is going to check if self is point to point. Then the process is super straightforward. The process will be link is a link and then interfaces will be self interfaces. That's pretty much it. And we need to self.topology.links. We need to add link. Okay. Else. For now I pass because this will require a lot of work. So now I would like to print. I can just use debugger here. I will have to add this function here that I want to self.create links from networks. Probably this will not need for now. Okay, so let me run debugger. So I have topology, and I should be able to see more links than I had before. Nice. Wait, why so many? Why so many? Oops. But no, hold on. So we had 4 serial links, and now I have 170. So, well, it may be fine. I just have to check here. So I have to go to networks. There are a lot of networks here. There are like numbers like 86. No, but this is still bad. Let's see what they say. Okay, I'm going to print all of those in such a way. So for link in topology.links, I'm going to print. Oh, and I can add the link. For the link, I can add the print str, which I have to do. For link, I need to add a wrapper, so I need to add def__wrapper, which will say return f string and interfaces will be self interfaces. And Then I also have underscore str. Well, I will say, well, this is f string, and I'm going to use like this. And let's say self interfaces I have a question for you guys. I want to create a function which returns either like first interface or second interface. How you would call this variable or function? Like probably like variable, because I want to create a, like, for now I am thinking about like first and second. So like link.first interface and link.second interface. Do you have better suggestions than this? For now I will create it and let me know if you have some other suggestion. So it will be first interface, self. Oh, oops. Let me add space. Let me, oh, what did I do? Okay. So let's see. I'm looking if all of those are unique links basically. I just want to understand before I move forward. Yeah, seems to be the case. Okay, that's cool. So I partially did this. I have to now edit for situation where there are more than 2 nodes on the same link. And let me go through. Do you, yeah, thanks for the question. Do you have network experience? So, yeah, the thing is, like with network automation, is that to automate stuff there, you probably need to understand how networks work. And yeah, so let me know if you have that. If you do, then so if not, then this is definitely what probably needs to happen first. Okay. So yeah, like probably the good place to start with network automation is to understand what you want to automate. And for that, probably you would need to talk to people who do network operation in the company. So, and like understand what are kind of repetitive tasks that you guys do. Do you create VLANs? Do you do like some subnet provisioning? IP space division and so on. And do you add, I don't know, static mappings to GCP server every so often? And you start from there. You ask people around, or if you are the person who does a network operation, this is a place where you want to start this use case rather than solving the problem that is not there. And then you take the tasks that causes some pain in the company, and you just start with automating that. It seems like in network engineering the obvious choice is Python. Like network engineers are hesitant to, most of them, let's say most of us are don't really want to learn programming, but those who do, they tend to use Python. So understanding how Python works, because there are some very good libraries, there are a lot of examples of network programming and network programmability and automation with Python. So Python would be a second step. If you have a more detailed question or follow up, let me know. Okay. So let's see the following. I had this function where I was checking if it's point to point or not, and if it's not point to point, I want to see those. Maybe all of those are point to point. What? All of them are point to point? Okay. This is some good news, at least for this topology. I think, yeah, I kind of want to move forward, but let me do this. I am going to I'm going to comment this. I'm going to run this again. Oh. Okay. So I am going to open the bug for this on the Git. But because I don't have an example file, I don't want to do work which may be not needed. Oh, this is not my project, this is my project. So let me go to issues and open a new issue. And also create some labels. Oh, there are labels already there. So net if networks may contain more than 2 interfaces. This is not taken into account. Yeah, I mean, good place to start is not to go technical, but build good relationship first, you know, so that you can easily speak to each other, so that you have that communication channel first. So and you know, like I cannot I'm thinking I'm pretty sure that in most of the companies there is a need for this. So you know, like there are some repetitive tasks, there are some boring tasks, and so on. So it's all about, you know, getting that information, understanding it, and converting it into like some tasks. So also on like top of what I said, like Python and stuff, Ansible also seems to be getting a lot of attraction in the network engineering. So it started like probably a couple of years ago, 1 or 2, that Ansible became quite popular in networking space. So also like understanding how Ansible works and what kind of modules are there for networks, it's a good place. You know, like some automation routine may be as simple as for our purposes we need this and this outputs, right, from 1000 nodes every hour, right? Or maybe we want to have some structured data from this, or maybe we want also to have it in Excel or on some web page, you know. So even like a simple idea like this can turn into an interesting network automation use case. Okay. Sure. Okay, so this is finished. You can say that create convert links method method class partially done. Check. Okay, so this is done as well. So have all the links add documentation for topology. No, please no. No, I have to do it. Documentation is important, and if you don't do it at the beginning, you never do it. But let's also here raise an exception, so if it happens, we know. Okay, and also for that bug, let me change it. I need an example to implement this. Okay. Okay, let's add some documentation. Create a link. No. Creates a link object. Cashless Cactus, thanks for following, man. So create link object. No, a link objects from network objects. Returns nothing. Modifies self topology object by adding a new link into self topology.links. Okay. Returns boolean true if only two interfaces are the part of network objects. Checks if only two interfaces are connected to the network objects. Okay, cool. This works. No, I cannot force myself to add more documentation today, and on stream it's also boring, so maybe I will do it between streams, like, because it will just take another 30 minutes with me fixing documentation. But if you guys really want to see me writing documentation, let me know. I can do that as well. Anything you like. Okay, so I will put it to the bottom of the stack. And this is not done. Check one. Create templates, convert topology. Okay, so templates. Okay, so I had one template which was link.json template, and it was this. And let me see this example source file. Yeah, so for IOL it will be a little bit of pain. I have to check something again. So this, what kind of values were here? So serial 10, serial 10. My problem here is that to get this adapter number and port number, this will require some work. Let me actually see what they do in the source code of GNS3. So adapter number. They almost have similar objects like a link, port. I have interface, node, and topology. Ha! So adapter number. So what I'm looking for, I want to understand how do they use this adapter number. I think it will be on the node level. Adapter. Okay. For all port in all ports, if all port.adapter number you know what? I think I'm going to add a new project. I create a new GNS3 project and get the source GNS3 file to understand more with this adapter number. So if all port adapter number is equal to port adapter number, no. I don't see it in the source code though. So I'm thinking, how can I get it? How can I get the port number, which is just an integer value? Understand how to get adapter number and port number for GNS3. So if it's IOL, iOS on Linux, I understand how we could get it from the name. But if it's not there, if it's not that, then okay. Yeah, I think I know what. No, I still need to understand how serial will work. Will serial say like 1 slash something, and it will be okay for it? I don't know. Port name segment 040. Okay, I will just do what I think I should do, and if for some use cases it doesn't work, then people can write to me and raise a bug or something like that. So I will need to get to the node object, and I think I can start minimizing those. And I think this will be the last thing I will do for today, so not so that I will still could do something tomorrow. Okay. So no, I need this node. I can. Okay. So the node object, if it's IL, we can do the following. We can say get adapter and port name self. So if the only situation where we are going to do it when the node type is IL, if self node type is IL, then do something else, arrays not implemented. This method is valid only for IL devices. Okay, so I need this function should be only for interface, so it should be here actually. And then I have to say if self.node.self node type is IL, then I will get the EVE name, and let's see. So they put just very short E0 something, okay. So here will be some regular expression, I think. So let's see, let's have IOL interface name hp red.compile, and I have to import this library. I have to compile, let's see, let's say from A to Z, AZ, and then there is number, and then there is slash, and then there is another number. And now here we convert this to the name group, and we'll say interface base name, or let's say just base name. So B like this. Okay. So this will be adapter number, and this will be port number. Okay, cool. So now I have to parse this, and so this will be IL interface name re, and then find iter, or wait, is it called regex? No. Python regular expressions much no key values for named groups. Find iter. So it will be find iter self on the string, which will be self EVE name, and this will be parsed values is equal to this, and then we can say, well, for key value in parsed values.items, I'm going to do set attribute on the object self for the attribute key with the value. Okay. And then I will call this function as set adapter port number. So, and maybe I also want to convert E to Ethernet. Depends on what was in my reference file. No, only this. Oh, what is this? VM. Ah, switch one. Okay. No, I think I will just do get here and then I return parsed values dot sorry, no, this it will be adapter number and port number. Adapter number parsed values port number. So now for every interface I can call this function. So what I'm going to do, I'm going to take this node again and then I'm going to print node 17, print for me get, oh no, interface is get the first interface and then print interface get adapter port number. Callable object iterator object is not subscriptable. What? It is not callable. This is strange. Python find iter not callable. Okay, let me just see documentation of find iter. Find iter, it says pattern string flags returns an iterator yielding match objects over all non-overlapping matches for a pattern. String is scanned. Oh, it's not named find iter, it's named group. Named. Group dict, okay. Oh, yeah, I just did it incorrectly. So here I say match this, and then I say group dict. Now it should work. Okay, so it returns that adapter number is 0 for and port number is sorry, this is 1, this is 0. Let's do the following trick. Let's do the following. For interface in not17.interfaces, I'm going to do the same things. I'm going to print adapter port. Okay. Okay. So let's see, where is this GNS3 project? This part. And where is my template? For links, create stuff like this. So for link, I can get adapter number, I can get port number, I can get node ID. Let me try. So I will try this, and I will stop once at least this part is working. So this part corresponds to basically all links. So this will be in my topology build JSON, build GNS topology JSON. Result is this. Okay, and how it's going to be. So for link in self.links, I also need to import JSON templates import JSON templates. Okay, so end result, how this GNS3 is structured. So the top level so it will be here topology and then links. So first of all, we will create, well, there will be another template with those base stuff, but for now let's just leave it like this. So let's say topology is equal to empty dict. Now a links is this links dict. So for link and self links, I'm going to get my template from here, and I need to substitute the values, which is link ID using format. Okay, so and links dig, is it a dict actually, or it shouldn't be, it should be array. Yeah, it's array of dicts. Okay, so links, let's say links JSON. So link JSON will be link JSON template, which is from JSON templates, and now I have to call format on this format, and here I need to be extra careful, so I need to pass everything correctly. Where is this template? Link ID. Okay, I can manage this. Okay, I say local adapter. Let's change local to first and remote to second. So now I just have to fill in those values. So I say link ID is equal to link.uuid. Then I say first I have to jump back and forth here. So first adapter number, first interface name, first node ID, and first port number. I will just copy this for now. Okay, first adapter number, let's see, adapter number, port number will be link dot, no, first adapter number, first port number will be link dot first interface dot get adapter port number, I think, and then we will have the same thing, which will be second. So first adapter number will be first adapter number, first port number will be first port number, first interface first interface name will be link dot first interface dot EVE name for now. Okay, and now the same. Oh, sorry, there is also first node ID. First node ID. It will be link dot first interface dot node, like here, like this. Okay, and now I change everything to second and pray. And then if all of this works, then I say add a links JSON add append link JSON, and now result dot topology dot not dot but another level of hierarchy will be links JSON, and there is very small chance it will work but that's fine. Okay, so I write configs and I build topology build GNS topology. I see. An interface object has no attribute get adapter port number. Let's see. Oh, okay. Key error filters. What? It's empty. Let's put here something for test. Oh, right. Obviously this is not .uuid. This is not .uuid. Second node ID is an invalid keyword argument for this function. Okay. Okay, this worked. So it says key error filters. So I don't get this. I have this string into which I just substitute the values. Key error and filters. This does not make sense to me. Do you guys see the problem? Because I cannot see it. Key error. Why it's referring to filters? Oh. Oh, okay. I see it now. This is not escaped. Tuple index. What? How can you have tuple index out of range? Let's see. I didn't give enough arguments. Okay. One, 2, 3, 4, 5, 6, 7. Oh no. Yeah, I have here everywhere this bracket, so I will have to escape everywhere. So this will not work. Python format parts of JSON. Don't use format function to substitute parts of JSON. There is a better way to do that with string template. I think I can actually do it. It's not be big of a deal. So like this, and then like this, and well, no, this will not work because I will have to go through each of this thingy and modify it. It shouldn't be so bad, no. Okay, let's try. So I will get this link JSON template, and I cannot use this anymore. So link JSON will be deep copy, import copy. So difference between copy and deep copies will create copies of the whole tree, and it will not be just references, so it will be an actual copy. This is what we need. We need an actual copies of the same thingy. And is it, what is it, copy underscore div copy? Yeah. So copy div copy, it will be again JSON templates, link JSON template. So now I have to go through this whole tree and say, for example, link ID will be self link UUID. Then link JSON. So first interface will be JSON will be a link JSON nodes 0. And second interface JSON will be nodes.1. And now I say adapter number is this. First interface JSON adapter number will be first adapter number and then node ID will be link first interface node UUID, and then port number will be first port number, and then the last thing will be label text is first interface name. Oh no, label text. So first interface JSON label text is this is link first interface.eve name. Okay, now I copy this part and here's this basically second. And now from this template I remove this part, I remove this part, I remove this part, these two parts, okay, so this will be false. Well, oh, okay, this is link.uuid. List indices must be integers or slices, not str. What? It's not str. Let's see. Oh, right, because it's link JSON. Okay. object of type UUID is not JSON serializable. Are you kidding me? So let's see, let's try this str. Okay, this I like. So, okay, the last step would be print this. Or maybe I will even, no, I will just print it for now. And let's copy this, the whole thing. Oh. Okay. Topology links filters node. Serial.1/0 is connected to another node, and nice. That's pretty amazing. Let's scroll this a little bit. So let's say here it says I'm connected here on the port E02 on one device to E02 on another device. Let's scroll even more. Like this. This one is connected to E11 on one side and on E00 on another side, and yeah, this actually looks great. Okay, so this goes to done. So in the end, those were not Jinja templates. Those were just dictionaries. Okay, so this is still to be done. So done only for links, but that's pretty good progress. Okay, so let me save this code to GitHub. So let's see. A lot of modifications. So git add a, git commit m, create link object, link and topology classes, convert links to resulting JSON. Git push. Okay. How big our project? So this one is topology is almost 200 lines. The main function is like 30. Node is like 350. So around 600-700 lines total for now. Okay, let's go. I mean, it's not big project, but it's also not like extremely small already. Okay, so guys, let's wrap it up for today. So on my YouTube channel you can find recording for part 1. Part 2 and 3 they will upload it either later today or early tomorrow morning, and when I say today I mean 29th of December. And part 4 probably it will also like be another day or two until it's posted. So I also hope that I will stream tomorrow, if not then on Sunday, to finish this project, because we are very close to the finish here. Thank you very much for joining and see you next time. Bye.